Bismillahirrahmanirrahim. Now we'll talk about derived random variables. Each sample value y of a derived random variable y is a mathematical function g of x of a sample value x of another random variable. So the notation y is equal to g of x describes the relationship of the two random variables. It means that this y of itself depends on another function g of x. So this g of x, the values of y will be derived from this g of x. So we have a look at an example of this, and that will help us to understand this concept. The random variable x is the number of pages in a facsimile transmission. X actually is the number of pages in a fax transmission. Based on experience, you have a probability model P of x for the number of pages in each fax you send. So with experience, we know that how many pages are sent in each fax. The phone company offers you a new charging plan for faxes: 10 cents for the first page, 9 cents for the second page, 8 cents for the third page, 7 cents for the fourth page, and 6 cents for the fifth page. For all faxes between 6 and 10 pages, the phone company will charge 50 cents per fax. So if you are gonna send a fax which has got only one page, then you have got to pay 10 cents. And if you have got 2 pages, then you'll have to pay 10 cents, and in addition to that 9 cents. So in total you will have to pay 19 cents. And you have got 3 pages, then you have to pay 27 cents, because 10 cents plus 9 cents plus these 8 cents. So that goes on up to 5 pages. You have to pay up to 40 cents. But after that, whether you are sending 6 pages or 7 or 10, 50 cents are added. You have to pay only 50 cents. So what we have to do is that we have to find a function y is equal to g of x, where y depends on g of x, for the charge in cents for sending one fax. So first of all, here we find the cumulative value of the amount, that is how many we have to pay for each in case of how many pages we are sending. For example, if one page is sent, then 10 cents have to be paid. In case of 2 pages, 19 cents, 3 pages, 27 cents, 4 pages, 34 cents, and so on. For number of pages 1 to 5, the function is defined as 10.5x minus 0.5 x squared, and for 50 cents for pages 6 to 10. As you can see that for pages 6 to 10, the rate is flat, 50 cents. If you are going to you have got 6 pages or 7 pages to be sent via fax, then you have to simply pay 50 cents. So for pages 1 to 5, the function is given as 10.5x minus 0.5 x squared. You can plug in the values of 1 to 5, and you will find that exactly these values you will get. For example, for 2 pages, you simply put 2 over here. So 2 multiplied by 10.5 minus 2 squared into 0.5 will give you 19. Suppose the faxes contain 1, 2, 3, or 4 pages with equal probability. So here now we are going to find the PMF, and we are assuming that the number of pages are 1, 2, 3, or 4. So it can be 1 page or 2 page or 3 page or 4 pages. Then that's the maximum limit of the number of pages. Find the PMF and expected value of the charge for a fax y. So here x is representing the number of pages, y is representing the charge where we have got to pay for fax. Now the solution is that there are 4 equiprobable faxes. Therefore P1 is equal to P2 is equal to P3 is equal to P4 is equal to 1 by 4. So all the pages have got the same equal probability. So since we have got 4 pages, so the probability of sending 1 page and 2 page or 3 page or 4 pages simply 1 by 4 for all of them. So the P of x, the number probability of sending pages 1 to 4 is equal to 1 by 4 and 0 otherwise. The charge for the fax y has range sy is equal to 10, 19, 27 and 34, as you can see it over here. 10, 19, 27 and 34. For page 1 10 cents, for page 2 pages 19 cents, 3 pages 27 cents and 4 pages 34 cents. So this this charge of x's correspond to the number of pages over here, s of x. So this is actually what we are saying, that this s of y depends on the number of pages. That's what we know. Here each value of y results in a unique value of x. So for 1 by 4 for y is equal to 10, 19, 27 and 34, because this value over here corresponds to this 1, 2, 3 and 4. So for one page the charges are 10 cents, for 2 pages 19 cents and so on. So the probability of charging 10 cents is again 1 by 4, because if the probability of x is 1 by 4, then the chances of you are going to be charged 10 cents is also 1 by 4. The probability of 2 pages sending 2 pages is 1 by 4, so the chances of for you to get charged 19 cents is also 1 by 4. So the expected value, as we have seen before, that is nothing but that we multiply this probability with this realization values. So 1 by 4 multiplied by 10 and 1 by 4 multiplied by 19 and so on, we get 22.5 cents on average. So on average we can say that how much you are going to be charged, that is 22.5 cents. Now we continue the same example. Now the only thing is that we have changed the values little bit. Suppose probability module for the number of x pages is given as 0.15, x is equal to 1, 2, 3, 4. 0.1 is for x is equal to 5, 6, 7, 8 and 0 probability otherwise. So the only difference between this example and this example is the this probability for number of pages and the total number of pages as well. Here the probability to send 1 page or 2 pages or 3 pages or 4 pages is 0.15, and 5 to 8 pages it is 0.1. So what is the PMF and expected cost of a fax? So in this case, as this will help you to understand that the PMF and expected value changes according to the given conditions. Solution is that probability of 5, 6, 7, 8 is the same, as we know that for if we go above the probability is the same for 5, 6, 7, 8, but the cost is different, because the cost from 6 pages up to 10 pages is constant, but up to 5 pages it is different. So the cost of x is equal to 5 is 40 cents and the cost of 6, 7, 8 is 50 cents. We have seen this over here. The cost for up to 5 pages is 40 cents, but if you go beyond that, from up to 10 pages it is 50 cents. This is constant. We add the probabilities of outcomes x is equal to 6, x is equal to 7 and x is equal to 8 to find Py of 50. P of 6, P of x7 and P of x8, which is equal to 0.1, which is given over here. The probability for each page 6, 7, 8 is 0.1 plus 0.1 plus 0.1 is equal to 0.3. So the probability P of I of for 50 cents is equal to 0.3. So as you can see, the difference is that here in this example the probability of charging 10 cents was 1 by 4, 19 was 1 by 4 and so on. The probability that you will be charged 10 cents is 0.15, the probability you will be charged 19 cents is 0.15, and for 27 and 34 is also the same. And the probability that you will be charged 40 cents is 0.1, and the probability that you will be charged 50 cents is 0.3. So expected value over here is 0.15 multiplied by 10, 0.15 multiplied by 19, 0.15 multiplied by 27, 0.15 multiplied by 34, 0.10 multiplied by 40, this 0.10 is multiplied by 40, and 0.3 is multiplied by 50. So the expected value is 32.5 cents, and it is very evident that the expected value must go up because the number of pages have increased from 4 to 8.